Well, good morning, class, and welcome to AP Statistics. We are in the probability chapter, and we just finished 5-2. So, um, since I'm not a fan of Venn diagrams, and I'm not a fan of the formulas in our formula sheet, I have discovered, and going to some different AP conferences and people showing me and talking to me what the new and improved way of doing probability problems, they're called hypothetical tables. And they work really well for probability problems. And quite frankly, these are the type of probability problems we're going to see the most of. All right, so we're going to hammer this sucker until our fingers are bleeding, just because we need to get it down, and it's really pretty easy. I really enjoy it. It's like Sudoku for me. And so, anyways, you should be getting a present from me. My Christmas present to all of you is the Big Book of Probability. And I'm going to first show you one that's not in the book, just so we can work through it. Then we'll work through one that's in the book and see how we do. So first of all, let's go through this hypothetical situation. It says two friends, Doug and Kathy, have cars in desperate need of repair. On any given day, the probability that Doug's car will break down is 50%. The probability that Kathy's car will break down is 60%. The probability that both cars will break down is 30%. What is the probability that Doug's or Kathy's car will break down? All right, so here's how we set it up. First of all, these are kind of like our total rows. All right, these are our totals. And so our overall total, we're going to assume, hey, let's say this happened 1,000 days. So we always write 1,000 down here. Always. Now, you might say, why do you want to do it 1,000? You could do it 100, I guess, if you wanted to. But I like 1,000 just in case we get some decimal points. So 1,000 kind of works well for me. Now, so we're going to say there's 1,000 situations like this. All right, we're going to say, here's Doug's car. Let's say this breaks down. Okay, so this will represent how many times Doug's car breaks down in a given day. Well, what's the probability of Doug's car? 50%. So how many days would that be? Well, if there's 1,000 days, it would break down 500 times in 1,000 days. All right, and then we always put the um, the reverse here. And so we're going to say Doug's car if it doesn't break down. So if it doesn't break down, obviously it's going to be the other bit, 500, right? So 500 days it will break down, 500 days it won't break down. Then we're going to go to Kathy's car. All right, now this is going to be the event that Kathy's car breaks down. So Kathy's car breaks down 60%, right? So I'm going to say out of 1,000 days, it would break down 600 times. So that means the event that Kathy's car would not break down, okay, would be 400. You guys with me so far? Filling out this table works out pretty slick, right? All right. Now, what we need one more box to fill out everything else. And that's all we need. Is we need really three bits of probability to fill out the whole hypothetical table. Says here the last one is that the probability that both cars will break down is zero point 0.3. So both Doug's and Karen's. Now remember, this is an and statement. So both Doug's and Karen's. The fact that it'll break down is 0.3%. So where is it that Doug and Karen both meet? Well, Doug is this direction. Karen is this direction. So where is it that they both meet? Here, this box. So what's the probability that both Doug and Karen will break down? Well, 30%. That means that 300 days out of those 1,000. Right? And this is all stuff we can do in our head. So therefore, I can fill in the rest. I know this has to total 600. So that means 300 here, right? Because 300 and 300 make 600. And I know this, how will this total 500? Well, this has to be 200 then, right? See how we're filling this all out now? And then what does this have to be? Well, to get to 400, this has to be 200 here, right? See how fun this is? And then just double check 300 to 200, does that give me 500? Yes. Perfect. Now I got my table done. Now my final question is, what is the probability that Doug's or Karen's car will break down? All right, so the probability that Doug or Karen's, let's do this upright too. All right. So I'm going to go up here to my highlighting tool. Now, here's Doug's. The probability his breaks down. Here's Karen's. Probability that hers breaks down. Okay. Now remember what I said yesterday about and or statements. Don't just take 600 and 500 and add them together and say that's the probability. No, because that would be 11,000 and we only have 10,000 or 1,000, right? So what I like to do, I'm going to do this in blue. All right, actually I'm going to undo what I just highlighted. Is take the one, here's my Doug's, here's Doug's, and here's Karen's, and I add up those, all right? Not the totals, I don't include the totals at all, I just add up this row right here. So I have 300, 300, and 200. That is 600, that's 800, oh, that is 800 out of 1,000. Which hopefully we should all know is 80%. So what's the probability that they'll both break down? Or that Doug's or Karen's will break down? 80%. 80% chance that one of them is going to break down the next day. See how it works? It's a hypothetical table. We'll do one more. All right, open up your big book of probability. Woo! All right, here we go. First one. The current college campus, 56% live on campus, 62 have campus meal program, and 42% do both. All right, so I'm going to fill this out. So I'm going to say live on campus. I'm going to illustrate this by campus. All right. So we're always going to have a campus, and then we're going to have the people who don't live on campus. So we're going to call those CCers. And then we have meal programs and non-meal programmers. So people who don't eat with a meal. And remember, we always put 1,000 down here in this blank. All right, now you can put the meals over on this side and the campus up here. It doesn't matter. That's the beauty of this. All right, now let's fill it in. So current campus, 56 live on campus. So 56, the total here for campus people is 56%, which is 560. Right? Okay, so right away I'm already doing math in my head and I'm saying that's got to be 440, right? The total up to 1,000. Okay, then meal program. 62% have a meal program. So that's 620, right? So then my math here, that's 380, I believe. 380, right? That'll add up to 1,000? I believe so. Now I need one more to fill in the rest. 42% do both. So what square is both? Well, this is campus and meals right here, right? This would be not campus and meals. But we say do both, so campus and meals. They said 42%, so that's 420 do both. That make sense? All right, now we got to figure this out. 420 to 620, that's I think 200 in there. And I think this is 140 here, right? 420 and 140 gives me 560. And then what'll add up to 440? I think that's 200 and 240, I believe. Will equal 440, and then just double check this. That'll equal 380, sure enough. All right, now I got it all done. Got my table done. You ready? What's the percent lives off campus and doesn't have a meal program? Now, this is an and statement. Okay? So they live off campus. So live off campus is going to be this row, and doesn't have a meal program. Now remember, and is the intersection. Where do they meet? So people who don't have a meal program and people who don't have a meal program and don't live on campus. Where do they meet? Well, that is 240, right? And statement is 240 all over 1,000, which is 24%. Actually, let's write that up in the answer. Okay? All right. Let me move this up here. Wrong one. There we go. 240 over 1,000. Remember, you always want to show your fraction when you're working. They will dock you points on the AP exam. So just make sure you always show your fraction. Lives in a residence hall, but doesn't have a meal program. I'm going to erase all this stuff, so hopefully you guys have it. All right, there we go. Lives in a residence hall. All right, so I'm going to highlight this. Lives in a residence hall. Boom. But doesn't have a meal program. Doesn't have a meal program. Okay, so this includes an and statement as well, right? Because which one do they, um, do they both have? So it's got to be lives in a residence, doesn't have a meal plan. That's 140. That's 140 out of 1,000, right? Equals 14%. See how easy that is? Then finally, a student who eats on campus. Sorry, this is taking way longer than I wanted to. Student who lives on campus. A student lives or eats on campus. So they live or eat. All right, now remember this or statement. It's not the intersection. So it's meaning both of them. So what do? I like to take this and I add that and that together. Don't include the totals. So it's going to be, let me clear that away. 200 plus my 420 plus my 140 all over 1,000. All right? So it's those three sections. Remember, if you're thinking of the Venn diagram section, what does this consist of? Three sections. 1, 2, 3. That's those three sections. 1, 2, 3. Okay, 200 would be here, the meal program. 420 would be in here. I'm not going to be able to fit it, guys. Oh, maybe. 420 would be in there, and then 140 would be over here. Now, I know it's not to scale, but that's all we're doing in the Venn diagram. You have to add all three of those together to make it up. And so that's going to be 620, 760. So 760 over 1,000. I believe, unless I calculated that wrong, that's 76% roughly. Boom, boom. Okay, that's how you do it, guys. So and statements are where they are unioned, or statements would be everything that's both highlighted. All right, so good luck. What your goal is today is to gather through all the level ones, and you'll see it says level 1 at the top. I think it joins in level 2. Is it page 7 or something like that? So on page 7, you can stop. But all the level 1s, if you want to try and take on a level 2 problem, go for it. You set up the thing the same way. It just gets a little trickier. All right, well, have a good one. Enjoy doing these, and then I think we have a video, traffic, for numbers, and one good thing to pay attention to is look at what he's got on his whiteboard. Right at the beginning, he's doing and/or statements. It's awesome. All right. Anyways, okay. Guys, love ya. I'll see you on Thursday. Adios.